Well, hello everyone. This is KP the Math G here, and you're looking at a problem that this is coming from the 2009 question, free response question number one, and on that particular one, Karen had a chart, a table, if you will, that deals with time versus velocity. And we figured out that her distance, of course, when you find the distance, you add up all the areas of all the shaded areas. Okay, from, in this case, I want to say from 0 to 12 minutes, or no, anyway, minutes, I want to say yes. Anyway, she is 1.4 miles away from school. We found that Larry lives 1.6 miles away from school, and I want to show you how. This is his velocity equation here, right here. Wt is equal to pi over 15 sine pi over 12t. We let u be equal to pi over 12t. Du is equal to pi over 12 dt. And multiply both sides by 12 over pi. You got 12 over pi du. So when we multiplied that, we got, the reason we got a negative because the antiderivative of sine is negative cosine. We already had pi over 15 here. We put that on the outside, and these pi's divided out, and we're left with negative 12 over 15, which is negative 4 over 5. And then, of course, cosine pi, when we put the 12 minutes in, 12's canceled out, and we're down to pi. And then here it was 0. So from 0 to 12. All right, and so cosine of 0 is 1, cosine of pi is negative 1. So negative 4/5 times negative 2 is 8 over 5, which is 1.6. And so we're seeing the conclusion is Karen lives closer to the school than Larry does. By only 2/10 of a mile. You don't really have to say that, but it's all right. Okay. All right, so that I was cut off. That's the reason I wanted to cover this one a little bit, because my time ran out. My recorder here, my video cam here, it just allows me a little over 30 minutes, and that's it. I had 31 minutes and 42 seconds, and that is the max for it. Talk about max and mins. Oh, there it is. Well, all right, we have another problem here. This is question number 3, and I want to do the last two parts of this one. Just to kind of brief you on this, that cable is $120 per meter. The cost to produce to kind of produce the cable rather is 6 times the square root of x dollars per meter, per meter, yes, per meter of cable, yes, this is to create the cable, all right, or produce the cable. And of course, this is a business wanting to buy, this is what they are charging to sell the cable, so they buy this from this, we might want to say middleman, or whoever it is that produces the cable. All right, so we want an expression involving an integral that represents the profit. Well, we do have a such thing as that. So what is profit? All right, profit, if you wanted to do something like this, maybe, let's see, P at X, all right, profit is equal to, okay, it's $120. This is the cost of the sale per meter, if we want to say times x, okay, minus, and we can use anything up here. Alright, so maybe 0 to ever how many meters you have, x right here, okay, and then 6 times the square root of x dx, and that's what you would do there. Okay, I'm looking at the problem, I'm just double checking here, and let's see, oh well, k meters long, okay, meters long, that needs to change there, and the k is up here as well, of course it is. Alright, so that's a general function that is related to, this is to profit. Alright, probably we could say P, okay, but anyway, profit. Alright, now that's the profit equation. You want to remember that because we're going to use that for part D, and that's where we're at now. Okay, so again, you want, this is the rate that it's being sold. Alright, this is the rate, 120, but the amount that's being made is times K. Okay, alright, and again the same thing here, and that could be easily done here. Alright, if I wanted to, but all we need is an integral expression, and that's it right there. Okay, the D part, I just want to leave this up here. Let's put this up here. Oh, I have to, let me erase, oh my goodness, I forgot I had this over there. Well, hold on just a second and I will have this erased in a jiffy. Oh, please bear with me just a little bit. I'm going to try to do this as fast as I can. Okay. I apologize for that, but I did want to show this problem because my time ran out and I wanted to make sure that anyone who didn't get that from the last video that I had, I did that from the last video and I wanted to make sure that people got that one. Alright, let's go ahead and do this one now. We are saying that D is find the maximum profit. Okay, find the maximum, alright, profit. Okay, now remember we just got through saying that profit is equal to, what do we say, 120 K, that's meters, and remember we're subtracting. This is how much it's sold for, but they're not going to make that kind of money. They have to subtract off. They got to pay this person off, whoever this is. This is 6 times the square root of x. Alright, the ones who produce this, alright, they have to pay them. That's why there's a minus sign here, and you're paying them for ever how many feet, or in this case meters, the cable is. Alright, so that is what we're doing here. Alright, so that's the profit. So now we want to take the derivative. I'm trying to find, I have a black marker that's really good and I probably have misplaced it, so I'm just going to grab another one right here. My markers are starting to run low. I'm got one here, but I don't know if it's working well or not. So we're going to give it a whirl. Now, it says maximum. When you see that word maximum, you automatically need to take the derivative of this. This is how much this is the amount of profit. Always remember, profit is an amount of money, right? In this case, amount of something. Just like when we talk about gallons of water, that's an amount of water. Well, this is the amount of profit here. So when we have to take the derivative to find maximum. If it said minimum, we have to still take the derivative. Okay? That first derivative there. Okay, so that's what we're going to do here. I'm going to have to get different. I tell you what, let's try red. That probably does about as good as any. Now remember, this is P prime. Yeah, well, if you want to, of any K, alright. Now, this is just 120, isn't it? When you take this derivative, that's just 120. And when you take the derivative of this part, that's that fundamental theorem of the calculus. So what we have here, I need to put this down a little bit further. I'm sorry. Alright, so P prime at K is equal to 120 minus, okay, now 6, just plug the K in here. Alright, right there. And that's it, basically. Alright, the derivative of K is 1. Alright, so there it is right there. 120, that is what we do there. Now remember, if we're looking for a max, we want this to be equal to, we want this to be equal to 0. Simple as that. You want to set this, you want to max, you want to get that derivative. That's why we're dealing with that C part. The C part was this. And when we use that to get this right here, you got to remember that fundamental theorem of the calculus right here on this one. This is an easy derivative. This is a no-brainer derivative right here. So we're setting that equal to 0. So we got 120. Let's add 6K to both sides. Times square root of K rather. 6 times square root of K. Alright, so now that is 120. This is gone, is equal to 6 times the square root of K. Working backwards, I'm going to divide by 6. 12 goes in the, 6 goes in 12 2 times, so 20. 20 is equal to the square root of K. So when we square that on both sides, 20 squared is 400. So K is 400. Alright, K is that would be what we would consider a critical number. This is N. Okay, so K is what we've found here, and that's what we're trying to figure out. It says the maximum meters is what we're trying to do. Now, if you were to do this test here, okay, so if you were to take this originally and plug in some number less than 400, let's say maybe, so let's say we got P prime at, let's get a number that goes well as far as the square root goes. Well, I tell you what, let's pick 100. Alright, so 120. Alright, so 100 is 120 minus 6 times the square root of 100. Alright, so 120 minus, let's see, square root of 100 is 10. Alright, so this is 120 minus 60. And of course, we know that that is equal to positive. Alright, and obviously this side is going to be negative. if we were to pick something greater than 400, let's see, let's say we pick, say, 900. Alright, square root of 900 is 30, right? And 6 times 3, that's 180. And this is going to give us a negative sign right here. 120 minus 80 is negative. So this is kind of like a max. If you think about a max, here's your height right here. The maximum height is, and this, well, it's not maximum height, but the maximum amount here of meters, 400. And to the left, this is positive, it's increasing. To the right, it's decreasing. And that's what a max is, right? From positive to negative. Okay, so we know that that 400 is the only number that we could choose, so therefore we can just plug that in. Okay, so let's take a look at the original problem again, and now we can figure out how much the maximum is. What is the maximum profit? Well, here it is. Profit again, we already know what the equation is. 120 times 400 minus, now we're integrating, we know it's from 0 to 400, and then 6 times the square root of x dx. Okay, if you want to go ahead and solve this, you can. I can do that, or we can just simply put it in the calculator and let it decide for you what that final answer is. And when we plug it in, we get, well, that's another problem. Okay, let's see, yeah, 16. Okay, so this answer is equal to $16,000. So when K has to be the max, K is the amount of meters. Alright, so at 400 meters, this gives us $16,000 profit. Alright, anything less than that is just not quite enough. Anything greater, you see, you see that the max is here, okay, from this problem here. Alright, and so that's the maximum profit, $16,000. Okay, I could quickly integrate this if I wanted to. You can, if you want to do it by hand. Okay, so I can put the 6 on the outside. This is x to the 1/2. Alright, I'm just doing this on the side. We know what this is. We can figure this out pretty quickly. Go ahead and figure that out. That is 120 times 400. Okay, this amount is 48,000. Okay, and then we would have to, that's in dollars, of course. Now we got to figure out the rest of this. This is dx here, so this is 6. Alright, now x to the 3/2. Now remember, plus 1 is plus 2/2. So x to the 3/2, and then of course we need a 2/3 in front of that x. So 2/3. I always like to flip it like that, and we are going from 0 to 400. We don't need the 0, because if we plug 0 here, this is just going to be, all of this is going to be 0. So now we're just going to take 400. So this is, well, let's see, 6 times 2/3 is, let's see, 3 goes into 6 2 times, so this is 4 times the square root of 400. And remember, we're cubing that. Alright, so square root of 400 is 20. So 4 times 20 is, well, let's see, hold on. That is 20 cubed, isn't it? Did we do that? Let's see. Square root of 400 is 20. We got to cube 20, don't we? Okay, so 20 cubed. Alright, that's 8,000. Okay, so 4 times 8,000. So 4 times 8,000. This is 32,000 here. So 48 minus 32. Alright, doing it by hand, you see that it does give me 16,000. Alright, there it is. I'm doing that by hand. Sometimes I like to do that by hand just to kind of get you, kind of keep you in line with this. And you know how to do this, but I don't know if they do allow this by calculator or not. This may be without a calculator. I'm not sure how the test goes. It's been so long for me to know that you have to have a calculator or not a calculator for this one, but if you don't have a calculator, you do need to know how to integrate this. Okay, that's that right there. So anyway, that's what we have here, 16,000. Our max is 400. And if I look at the answers here, and maybe, okay, so it says this is the only critical point for P. P prime changes from positive to negative. Maybe you might need to emphasize that at K equals 400. You need to emphasize that. Therefore, the maximum profit P at 400 then is $16,000. Alright, that's it. That's what we have to do. So every once in a while you do get into a max or a min. So if you have this, anything like this, you got to take that derivative to get that maximum or that minimum. You got to remember to do that. Okay. And then once you do that, plug this 400, not back in here, not back into your this here, because all you're going to get is 0 there. Alright. Alright. You plug it back into your profit right here. Alright. And then of course, we already figured out how to do this here. Alright, that's KP. This is KP the Math G signing off. Make sure you hit that subscribe button if you haven't done so already. Make a comment if you'd like to. And hit that, what's that? That like button. Yeah, I like that. You see me smiling when I say that like button. And the subscribe does look good too also. I'm gradually getting more and more subscribers, but I do appreciate every one of you, and I especially appreciate your patience with me in erasing all of this and getting all this together here and working on getting you a really good, that's what I want to do, give you a good product for you. Okay, I want to say this is the 116th video. I'm proud to be able to do this for you and to help you in any way that I can. KP the Math G signing off. Ladies and gentlemen, have a great, great day.